This next comment is extremely important for you to realize. We realize that a probability of 0 means something can't occur, and a probability of 1 means it must occur, guaranteed to happen. So what numbers could we get for probabilities? Remember, probabilities are usually written as simplified fractions, but the value of that simplified fraction must be between 0, meaning it's impossible, and 1 means it has to happen. So anytime you get an answer for probability, if it says determine the following probabilities ever, whatever your answer is has to be a number with value between 0 and 1. Remember, 0 means it can't happen. 1 means it has to happen. Okay, so let's move on to the next example. It says consider rolling 2 standard 6-sided die and summing the total of the pips of the following problems. So this is going back to the chart that we created on the previous page. What is the probability that the sum is 8? We'll go to the chart on the previous page and count how many 8s you see. If I look at the probability of creating an 8, the probability of creating an 8, or rolling an 8, it looks like I could have rolled a 6 and a 2, a 5 and a 3, a 4 and a 4, a 3 and a 5, or a 2 and a 6, but there was a total of 5 of those options. We'll look at the answers. There's 6 options for the first die, 6 options for the second die. 6 times 6 is 36. So it looks like there's 36 total possible that I could roll if I roll 2 die. So I have 5 8s in that chart, and I have 36 total. 536 is a simplified fraction, so that's our answer to the problem. What about the sum greater than or equal to 12, or greater than or equal to 10? Go on the chart and look at how many 10s, 11s, and 12s you see. If I look at the 10s, 11s, and 12s, it looks like to me the probability of it being greater than or equal to 10, I'm seeing a total of 6 numbers that are greater than or equal to 10. And again, there's 36 total possible. 6 over 36 does simplify into 1/6. So what's the probability of rolling a die where the sum was greater than or equal to 10? 1/6 would be that total possible. What about the sum is odd? So how many there's no ones, sorry. How many 3s, 5s, 7s, 9s, and 11s do you see? So what's the probability of it being odd? Go to that chart, count how many 3s, 5s, 7s, 9s, and 11s, the odd options that we have. Seems to me that we have 18 total of them, 18 of them that are odd, and 36 total of them. Go ahead and simplify that, and the answer I'm getting is 1/2. Again, this makes sense because half of the entries in that table are odd, half of the entries in that table are even. What's the probability of getting a 1? Well, look in that table. The smallest sum that you could get is a 2, so you can't get a 1. Remember, if you can't get a 1, that's 0 of the 36 total options that you see in the chart, which is 0. Again, meaning it can't happen. So we move on and we want to look at the sum is less than 14. Well, if I look on that chart, it seems that every single number in that chart is less than 14. Every number is a number between 2 and 12. So that means all 36 of the 36 entries are less than 14, which gives me a probability of 1. Again, meaning that must happen. Again, just note, I am boxing these answers and showing them in my visible screen. Please make sure you're putting these answers in the final answer blank provided to the right. All right, so 6-sided die aren't the only kind of die that you can have. There are multiple-sided die, and again, had we been in class, I would have been able to show you examples of die with multiple sides. So let's look at this. What's the probability of rolling a 5 on a 12-sided die? Well, now the probability of 5, instead of it being one of 6 sides, it's one of 12 sides. Again, that's the total number of sides and the total number of 5s that we can get. All right. What about rolling an even number on a 20-sided die? So what even numbers are there? Well, there's 2, 4, 6, 8, 10, 12, 14, 16, and 18. We can even roll a 20. So let's count how many that is. I'm seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of getting even happened 10 of the, well, it's a 20-sided die, so there'd be 20 possible. So 10 of the 20 again would be simplified to be 1/2. The probability of rolling an even is 1/2 on a 20-sided die. How about rolling a number less than 4 on a 10-sided die? So what numbers are less than 4? Well, that'd be the numbers 1, 2, and 3. So the probability of less than 4 on a 10-sided die would be 3 of the 10 sides of the die. 3/10 would be our answer. What's the probability of rolling a 5 on a 4-sided die? Well, let's think about it. The probability of a 5 on a 4-sided die, so there's 4 total sides, but none of those sides would be a 5, so that would be 0 of the 4, which simplifies to 0, again indicating that it would be impossible to roll a 5 if you had a 4-sided die. How about rolling a number less than 20 on a 12-sided die? Well, again, we want to think about what's the probability of getting less than 20 on a 12-sided die, so there's 12 sides total. How many of those sides are less than the number 20? Well, all 12 of the sides are a number value less than 20, so that's 12 over 12, which is a probability of 1, again indicating that this must occur.